Hello, sixth graders. So today we're going to continue with topic 5, and we're going to continue creating tables based off of patterns and equations, but we're also going to be graphing these tables now, and you'll see exactly how we're going to do that. So let's look at this first example. It says Nancy walks 2 blocks to Maria's house. Together they continue the walk. Graph the equation n equals m plus 2, where n is the number of blocks Nancy walks and m is the number of blocks Maria walks. So again, we're given all of the blocks Maria walks right here. And just like we were doing yesterday, we could take these values for m and plug them in. So whatever m is, Nancy walks 2 more. So 1 plus 2 is 3. 3 plus 2 is 5. 2 plus 2 is 4. And 4 plus 2 is 6. And again, they are not in order, so you can't rely on just either adding 2 within or subtracting or adding 1. You have to plug it into the equation. All right. And let's look at the next one. Let's just complete all of these tables right now. So this one right here is y equals 2 plus x. So again, we can plug in all of these and get values for y. Okay, so do that right now. Plug in all of these values in for x and see what the corresponding y is. So we have 2 times 1 plus 3. So 2 plus 3 is 6. 2 times 3 plus 3, so 6, 7, 8, 9. 2 times 2 plus 3, which is 4 plus 3 is 7. And 2 times 0 plus 3, which is 3. Okay, and lastly, this is a strange one, y equals x. So if you plug in all these values in for x, well, it's just saying that it equals y. So all of these are the same. So if you plug in 1 for x, 1 is y. Plug in 3 for x, 3 is y. 2 for x, 2 is y. 4 for x, 4 is y. Okay, so now what we have is we have tables that have x values, and we have tables that have their corresponding x values and their corresponding y values. So without even knowing, you were really creating ordered pairs. Okay, so for this example right here, if x is 1, 6 is y, we can write the ordered pair as 1, 6. And for the next one, 3, 9. We're really creating ordered pairs. From this table, we can get those x, that x and y, and create an ordered pair and graph it. It's pretty cool. Next one is 2, 7, and 0, 3. So we just got 4 ordered pairs from this graph. And the same thing with these ones. We can do 1, 1. 3, 3, 2, 2, 4, 4. Now the last one, it's a little weird because we have m and x, okay? It doesn't say x or y. If there's not an x or a y, it always goes left to right. So the m is actually an x and the n is a y. So we would read it left to right. And if the table is front and bottom or top and bottom, it will be x up top and y on the bottom. Okay, so now we can still get these ordered pairs. It would be 1, 3, 3, 5, 2, 4, 4, 6. Okay, so this is where you might be thinking, why are we creating these tables? What are we doing? Okay, well, the whole reason we're creating these tables is to now transfer what we have on these tables to an actual graph. So we can plot all of these ordered pairs on the graph and create a line. Okay, and this is very, very popular and useful in a lot of statistic things. Okay, so in things that deal with probability and statistics and measuring certain things, a lot of tables are created, and then people basically from that information transfer it onto a graph so it's easier to read. Okay, so what we're going to do, we're going to do the same exact thing. We're going to graph those 3 equations we just found ordered pairs for, and we're going to plot them on this coordinate plane. Okay, now you may have to go a little bit back and forth for this, so I do apologize for that. But let's do the first one. Okay, the first one is n equals m plus 2, and our ordered pairs are 1, 3, 3, 5, 2, 4, 4, 6. So let's start with the first one, 1, comma 3, and I think it's red. Okay, now you have these dots which are movable, so you can move these dots where 1, 3 is, but I'll just put my dot on there. So the origin, I'll put the origin as a big black dot right here, okay? The origin is right here, and then you have over 1 up 3. So the first ordered pair is there, so you could drag your red dot there. The next one is 3, 5. So over 3 from the origin, up 5, right there, okay? The next one is 2, 4, okay? So over 2, up 4 right here. And the last one is 4, 6, over 4, up 6. And you can see right now that if you were actually to connect all of these, it would form a straight diagonal line. And this line actually has a name. This line is linear, okay? And all of these equations right here are going to form straight lines because they are linear equations. And that's not really a word we're going to talk about too often, but you may hear that later in your life. Linear equations, the line is linear because it's a constant, okay? So this is a constant. It's going to always be here. And if I were to try to guess other points, I would think that there would be other points on this line as well. Okay, so a good thing with linear equations is if you are plotting this and you see a point that's right here, something might be a little wrong with your plotting because it's not in the line that everything else is, okay? So all of these should form straight lines, okay? So now let's look at the next one. And again, you're dragging your own dots to this table. So y equals 2x plus 3, which is this one. The first ordered pair is 1, 6. So again, you can drag your blue dot over 1, up 6, which is right here. Okay, the next one will be 3, 9, over 3, up 9, right here. The next one is 2, 7, over 2, up 7. And the next one is 0, 3. So, I know what I did. So this one, actually, I messed up. See, look. I actually like how I did this. So if you look at this graph, all of these points line up except for this dot right here. So I actually caught my own mistake because I didn't do this dot correctly. The point is not actually 1, 6. And I can look over here and see 2 times 1 is 2 plus 3 isn't 6. It's actually 5. Okay, that's actually 5. So really this point shouldn't be there. And that makes sense because it didn't really match up with any of the other points. Okay, so 1, 5 is actually right here, which, look at that, perfectly fits on my line. Okay, so this is the next one. It's y equals 2x plus 3. It also forms a straight line. It's a linear equation. That's why it's a straight line, because it's constant. And the last one, y equals x, which is green. We have 1, 1, over 1, up 1. We have 3, 3, over 3, up 3. We have 2, 2, over 2, up 2. And we have 4, 4, over 4, up 4. And this one is y equals x, goes right through that origin, straight through. Okay, so all of these equations, again, are linear equations. They are constant. They form straight lines. And we're going to be doing a little activity with creating these lines in a little bit later on in this week. But today we were just kind of taking these tables, finding ordered pairs, identifying the x coordinate, the y coordinate, and creating an ordered pair from that information. And then we were just graphing those ordered pairs, and we can come up with a bunch of different points because they're all on those lines. All right, and this is kind of the fun part. And this is honestly the very statistical part of all of this math, because you see graphs a lot, especially now with everything that's going on. You see a lot of like info, like graphs that have a lot of information on them. And it's all those people that they're creating all of these tables like this, and they're putting all of that information onto a graph so it's easier to see. All right, so what you're going to do, you're going to, again, just like this, you're going to have a bunch of tables, and you're going to have to plot those ordered pairs that you create from the tables onto a coordinate plane, just like this. All right, so it's going to be a Google slide. So you're not going to have a Google form again. You're going to have a Google slide instead, and it's not going to be attached to this Edpuzzle. It's actually going to be in your Google Classroom. Okay, so make sure you complete that for homework today. And if you do have any questions, please let me know. Have a wonderful day.